called Gruppo Helica.E3, as you can see. In this assembly we have a component, the green one here, called cilindro, that is not actually the final component, but it's just a part used to take into account the maximum bounding box of the n components positioned in the assembly. This component contains the symbolic references asse, rondella elica, rondella cilindro, and therefore it will be possible to replace it with components with the same symbolic reference. Let's start positioning some in order to learn the features of symbolic references. Insert component xref and then let us load Gruppo Helica.E3, as you will see now. Okay. Gruppo Helica.E3, it's a helix group. Let's confirm the emptying of the undo-redo buffer, and then let us position the component close to the assembly as shown in the movie, and let's enlarge the area. Let's now enlarge the area we shall use in our mating operations through a zoom window. Let us now start the mating command, and first of all let's see how to position the washer. Under More option, we have the symbolic reference only checkbox, which can be available or not depending on our choice in system. But I mean in system options, under constructions, we have use symbolic reference. If this box is checked, then the mentioned checkbox will appear under More options, while if the former is not checked, the latter will not be available. Let us therefore check symbolic references only. This means that when the cursor gets close to a component, we shall be able to select only those faces having a symbolic reference associated with them. Let us properly rotate the model, and let us start by selecting the inferior face of the washer. Here we are rotating, and so now we can select the inferior face of the washer. The program shows it as a symbolic reference, and then we can position it in coincidence onto the assembly face as displayed in the movie. Another mating operation can be the one of concentricity. Let's then select the washer hole and the pin of the cilindro assembly. Okay, and let's exit the mating command. Now, if we check the tree structure, we can see that also all the symbolic references that were used are represented through their own icons. So is the coincidence between rondella helica in the component and rondella helica in the cylinder assembly anti-aligned, and the coaxiality between asse and asse albero. Let's take a closer look at the tree just to show our icons and enlarge the model structure to see it better. Let's now load another X reference. So insert component X reference, and let's choose the helix nut dado helica.E3. Let us position it close to the cylinder assembly. Let us start the mating command, and we will be enabled to select only faces with symbolic references, also on the helix nut. Let us now suppose, just for a moment, to uncheck symbolic references only. We shall then be capable of selecting any face. For instance, okay, so let us now uncheck symbolic references, and let us select the rear face of the helix nut. We rotate and properly enlarge the model in order to be able to select it, which has no associated symbolic reference, and we can apply a coincidence mating constraint between it and the plane face of the cylinder component. Okay? Moreover, let us select the internal hole of the nut, symbolic reference asse, and the symbolic reference of the cylinder pin. Okay, if we take a look at the mating events we created in the tree structure, we shall notice a coincidence between a not symbolic and rondella helica of the cylinder component anti-aligned. So let us now redefine this coincidence by right-clicking on the icon in the tree and choosing Redefine in the context menu. Let us make sure symbolic reference only is selected, and let's click on the knot. So, and let's click on the knot, which will be automatically rotated while the symbolic reference rondella dado will be selected and replaced also in the tree structure once the command has been confirmed. And now let's replace the cylinder component. Let's first fit the view. We shall replace cylinder with a 4-blade helix called helica 4 pale.e3. From the structure we can immediately see the symbolic references are the same. Using view symbolic references, we can see they are properly positioned on the faces and on the whole. Let's right click on cylinder and let's choose replace. Okay. In the replace component dialog box, let's select the keep mating events option, which is made possible thanks to the name coincidence of the symbolic references. Let's then click OK. Now we can select the 4-blade helix. Let's confirm and rebuild the model. The 4-blade helix has replaced the previous cylinder component using the symbolic references and has kept the mating events. Obviously, the 4-blade helix can be replaced with all components containing the same symbolic references, such as, for example, the 2-blade helix, helica.e3. Okay, let's now replace it with the 2-blade helix, that is in component helica.e3. With rebuild, we can now see the 2-blade helix. Let's now take a look at a further small assembly which will enable us to learn the behavior of the solve ambiguities command, the third button of the symbolic reference toolbar. So, let us now open assembly assieme.e3. Let us replace component 500242222 with another component that we shall first open on its own just to see how it is built. Let's load 500242222_1, which has two symbolic references associated to two different entities, but with the same name. You can see it using view symbolic references. Let's then perform the replacement in the previous model with keep mating events. So replace, keep mating events. Let's open the one with _1 as soon as we can here now, and the following question shows up: symbolic reference ambiguities found, solve them now. Let's click yes. The two symbolic references are shown, one of which selected by default. You can choose either of the two or simply confirm, which is what we are doing. If we then start the solve ambiguities command, we shall have the same situation as before, in which I can choose either of the two or one of the selected by default. If we selected the other whole, click whole and perform a rebuild, the component will be automatically repositioned on the other whole. So, solve ambiguities at any time after the original mating event enables us to change the symbolic reference used in the mating itself, and thus to reposition the component with reference to the other symbolic reference with the same name.